Okay, another important relationship in gases is called Boyle's Law. And so Robert Boyle was studying the relationship between volume and pressure of a trapped amount of gas at a constant temperature. So the idea here is that if you take a sample of gas that is trapped, say, within a piston, and you increase the pressure that's exerted on this gas, the volume will decrease. That is, another way to say that is if you decrease the volume of a trapped amount of gas, the pressure inside that gas will increase. And again, this is called Boyle's Law. And what this basically says is that pressure, excuse me, I'm going to say volume, that the volume of a gas is proportional to 1 over P. That is, it's inversely proportional to pressure. As volume increases, pressure decreases, and vice versa. And you may have had some personal experience with this, right? If you've ever gone scuba diving or have even been in a deep pool, you know that as you release air bubbles and they rise up to the surface, those air bubbles expand. So for example, if you have a deep sea diver down at about 90 feet where the pressure is approximately 3 atmospheres, and you let out an air bubble down at that higher pressure, as it rises to the surface, the bubble will expand. And the question is, how much will it expand? Okay, so if initially each air bubble is 2 cubic centimeters or 2 milliliters in volume at that 3 atmospheres of pressure, when they reach the surface where the pressure is 1 atmosphere, what happens to the volume? Okay, and this is a simple relationship of, hold on, these guys down. It's a fairly simple calculation, and this is what we call an initial and final condition. Okay, so here basically what Boyle's law says is that pressure times volume is a constant. That is, they're inversely related. So we can come up with a relationship like P1 V1, my initial pressure and my final pressure, is equal to P2 V2. Okay, so since I have a trapped amount of gas, N is constant, and I'm going to assume here that the temperature is also constant. So in this particular problem, we have our initial pressure is 3 atmospheres, right here, and our initial volume is 2 cubic centimeters, and then we have a final pressure of 1 atmosphere. So the final pressure is smaller than the initial pressure. So in this equation, we're going to say that P1 is equal to 3 atmospheres, V1 is equal to 2 cubic centimeters, and P2 is equal to 1 atmosphere. So now with this expression, we are going to rearrange. We're going to solve for our final volume. V2 is equal to P1 V1 over P2. Okay, so we have 3 atmospheres times 2 cubic centimeters divided by 1 atmosphere as our final pressure, telling us that our volume is going to increase threefold, basically. So our final volume of our bubble will be 6 cubic centimeters. And so that's just sort of a very basic example of using Boyle's law. Again, here we are identifying initial and final conditions, recognizing that this product of pressure times volume is a constant, because again, our relationship states that volume is inversely proportional to pressure. So we can say that P times V is equal to a constant, where this constant will be our proportionality. Okay, so let's take this the next step further. So if we have at 25 degrees a sample of hydrogen gas occupies 0.4 liters at a pressure of 760 torr. Okay, the question is, what volume will this gas occupy if we change the pressure to 3 atmospheres, assuming that the temperature remains constant? And another assumption we make here is that the number of moles of gas doesn't change, because we're talking about a fixed amount of gas. So here, the critical pieces of information are our initial volume, 0.4 liters. Our initial pressure, 760 torr. And here is our final pressure, 3 atmospheres. Okay, so here the first thing we need to do is recognize that we need to be using the same pressure units. So 1 atmosphere is 760 torr, so basically P1 is equal to 760 torr, which is equal to 1 atmosphere. V1 is equal to 0.400 liters, and P2 is equal to 3 atmospheres. So this is basically the reverse of the problem we just did. Okay, instead of having the volume expand as it goes to a lower pressure, we're compressing this gas under a higher pressure, and so we're going to solve for V2 equals P1 V1 over P2, which is equal to 1 atmosphere times 0.400 liters divided by 3 atmospheres. So our volume is going to decrease by 1/3. 0.4 divided by 3 tells us that our new volume is 0.133 liters. The number of moles has not changed and the temperature has not changed, and so we are going to simply calculate that new volume using this relationship that we call Boyles Law.